So, here's a question for you. Is the AI that's everywhere now actually intelligent? Or is it just an incredibly good parrot? Today, we're going to dig into a really cool study that puts AI through its paces with some simple puzzles, all to figure out what's really happening inside that black box. Okay, so let's get right into it. The main question here is a lot like something you'd see in school, right? Is the AI genuinely understanding the idea behind a problem, or is it just memorizing all the answers from the study guide? And that difference is absolutely crucial. Which brings us to our first section. How in the world can we even tell if an AI is faking it? This right here, this is the heart of the whole problem. There's a reason we call neural networks black boxes. I mean, we can see what goes in and we can see what comes out, but everything that happens in the middle is just this tangled mess. So to figure out if it's really learning a rule, like a real function, or just being a mimic, we need a really carefully controlled experiment. And this is exactly how they did it. Instead of using messy, real-world stuff, the researchers use what are called formal language tasks. Think of them as simple little string puzzles. Because the rules are perfectly clear, there's no gray area. The AI either gets the rule or it doesn't. Simple as that. So what were these tests exactly? Well, welcome to the proving ground. This is where we get to see what these AI models are really made of. The AI model they're testing is a specific kind called an RNN-seq2-seq model. Now, that's a mouthful, but you can basically think of it like a human translator. The first part, the encoder, reads a whole sentence in, say French, and tries to get the gist of it. Then, the second part, the decoder, takes that summary and writes out a brand new sentence in English. All right, first puzzle. This one's the easiest, the identity task. The AI just has to learn how to be a perfect copycat. See ABC, output ABC. Easy enough, right? This is kind of the baseline. If it can't do this, well, it can't do much of anything else. For task 2, reversal, we're turning up the heat just a little. Now, the model has to see ABC and spit out CBA. It's a test of its short-term memory, really. Can it hold that whole sequence in its head and then play it back in the opposite order? Now for the third task, total reduplication. Here the AI needs to take whatever you give it and just repeat it twice. So ABC becomes ABC, ABC. This means it has to hold the entire string in memory and then write it out perfectly 2 times in a row. And now for the final boss, quadratic copying. This is the real test. The AI has to copy the input string a number of times equal to how long it is. So, since ABC has 3 letters, the output has to be ABC written out 3 times. This doesn't just need memory, it actually has to count. So, how did our little AI student do? Well, let's take a look at the results, starting with the stuff it was trained on. Its practice test. As you can see from this graph, wow, the results were pretty incredible. For strings that were about the same length as the ones in its training data, between 6 and 15 characters, the models got almost 100% accuracy. It looked like a total star student who had completely mastered the material. But then came the final exam. The second the researchers gave the AI strings that were just a little bit shorter or a little bit longer than what it had practiced on, performance just completely fell off a cliff. Those near-perfect scores, gone. It couldn't generalize the rule. Not at all. Okay, so maybe the basic model just wasn't powerful enough. The researchers decided to give it a bit of an upgrade, a kind of AI superpower called the attention mechanism. So what exactly is attention? Well, think of it like giving the AI model an open book test. As the decoder part is writing the answer, it can constantly peek back at the original question to focus on the most important parts. It's a huge help, and it's designed to stop it from forgetting key details. And as you can see in this table, attention made a massive difference. The models learned way faster, their accuracy on the practice stuff was even higher, and their ability to generalize was better. But, notice that little but there? Yeah, there's always a catch. And here it is, the knockout punch, a direct quote from the paper. Even with this powerful upgrade, the fundamental problem was still there. Even with the ability to pay attention, the AI still couldn't truly learn the underlying rule. It still failed the real test. So all of this brings us to the final verdict in this really fascinating investigation. What have we actually learned about what this AI is doing? So the takeaways here are pretty crystal clear. These models are incredible at faking it. They can approximate any pattern you show them. They're like that student who gets a perfect score on the practice test just by memorizing the answers. But the moment you give them a new problem that requires them to apply the actual principle, they're lost. And even giving them a superpower like attention doesn't fix this fundamental gap. And look, this isn't just some abstract academic thought experiment. This distinction, it's everything. It's the difference between a translation app that has memorized a million phrases and one that actually understands the rules of grammar. One of them is a useful tool, sure, but the other one, that's a real step towards genuine understanding. So I guess we end on this thought. These experiments used super simple, clear-cut puzzles. If our most advanced models can't even grasp the basic rules here, what does that mean for their ability to handle all the nuance, the ambiguity, and the insane complexity of our real world? It's a question we really need to keep asking.